spend a little bit of time here talking about inverse matrices, and a little later on in this lesson, we'll explore how we can use inverse matrices to solve systems of equations. But first, we're going to work on verifying whether two matrices are in fact inverses of each other. Now, we got a lot of inverses in math. I mean, the subtraction's the inverse of addition and vice versa, and multiplication's the inverse of division. And so we see inverses over and over again through our journey through mathematics. And so it makes sense that we would have inverse matrices. Now, what determines whether we have an inverse matrices? If we multiply, and here we got two matrices, x and y. If we multiply x times y, and if it equals the identity matrix, and what is an identity matrix? Well, I'm glad you asked. It takes this form here, 1, 0, 0, 1. That's an identity matrix for a 2 by 2 matrix or matrices. And if I also multiply y times x, and it also equals an identity matrix, then those two matrices are in fact inverses of each other. Now, when you look at your book, it shows you how to go through there algebraically, but we know that when we multiply two matrices together, and we do it algebraically, it's a pretty tedious job, and there's a lot of opportunities to make mistakes. And this is where our calculator becomes our friend. And so I really want to show you how to do it. We're going to perform these operations on a calculator, where really all we got to do is just input everything correctly, and we'll get the appropriate answer. So let's move to the calculator, and what we're going to do is we're going to build matrix x, and we're going to build matrix y. Then we're going to multiply x times y and see if if we get the product as an identity matrix. And then we're going to multiply matrix x times matrix y times matrix x and verify that we get whether or not we get the identity matrix. And if we do in both cases, well, shazam, they're inverses of each other. Well, here we are on our calculator, and thank God I've got a calculator. If you don't have one, you're in big trouble. All right, so I'm going to first build the two matrices that we saw, x and y. So I'm going to go to second matrix. We're going to edit matrix A first. Now, matrix A that I'm working with is a 2 by 2, so I need to change the dimensions to a 2 by 2 matrix. And let's see, it was 4, -1 across the first row, and the second row was 2, -2. All right, that looks good, so I'm going to hit second quit. I've done matrix A, but I'm going back into matrix again, second matrix, going to edit. And this time I'm going to choose option 2, which is matrix B. And again, I got to change it from my previous work to a 2 by 2. And let's see. Oh, need to go back. 2 by 2. All right, so that matrix is 1/3. So 1/3. What did we do wrong here? Oh, inadvertently hit twice there on the division sign. I always love getting that, hey, idiot, you did something wrong message. All right, the next one is -1/6. Then we got 1/3 again. And then -2/3, so -2/3. Okay, all right, that all looks good. Let's hit second quit. Now I want to multiply, first off, I'm going to multiply matrix A. So second matrix, I'm going to choose option 1, matrix A, times matrix B. Go back into matrix. This time I'm going to choose the matrix B, or the option 2, hit enter. And you see I got an identity matrix, 1, 0, 0, 1. Now, to completely verify that these are inverses, I need to also multiply matrix B times matrix A. So let's do that. So let's go matrix B. This time I'm going to choose an option 2 first. And that's going to be times, and I probably really don't even have to put that multiplication symbol in there. I just like to. This time I'm choosing matrix A, B times A. Okay, let's hit enter. And Shazam, it also is an identity matrix. So since A times B is an identity matrix and B times A is an identity matrix, those two matrices, X and Y, in our example here, are in fact inverses of each other.